Next we are going to discuss derivatives of implicit functions. So let us see what is meant by an implicit function. There are two types of function, implicit function and explicit function. In explicit function, y is directly given as a function of x. So the form of an explicit function is y is equal to f of x. Say for example, when you write y equal to sin x, y is equal to 2x plus 3, y is equal to log of x square plus 1, all these are explicit functions. So y is directly given as a function of x. Whereas in implicit function, y is not directly given as a function of x. Y is indirectly given as a function of x. How is it? The relation between x and y is given in the form of an equation f of xy equal to 0. For example, look at this equation, x square plus xy plus y square equal to 0. It is of the form f of xy equal to 0. So here directly y is not given as a function of x, but indirectly we can see that there is a relation between x and y. Such functions are known as implicit functions. Now today we are going to see how we will find derivative of an implicit function. So to find derivative of an implicit function, we differentiate both sides of the equation with respect to x. So take dy by dx on both sides of the equation. Now, when there is a product of function, use product rule. Use product rule wherever applicable. Wherever applicable. Then, when you are differentiating a function of y with respect to x, that is when you are finding dy by dx of f of y, differentiate the function of y with respect to y, then multiply it with dy by dx. This is an important rule when we are differentiating a function of y with respect to x. Differentiate the function of y with respect to y, then multiply it with dy by dx. Now, finally, take the terms with dy by dx on one side and the terms without dy by dx on the other side and divide it and find dy by dx. Let us take one example. X square plus 2xy plus y square equal to 0. So this is an implicit function and our question is find dy by dx. So we differentiate both sides of the equation. So we take d by dx on both sides. So d by dx of x square plus 2xy plus y square equal to d by dx of 0, that is equal to 0. Now here we differentiate term by term, that is d by dx of x square plus d by dx of 2xy plus d by dx of y square is equal to 0. Now d by dx of x square, you know that it is 2x. Here we take 2 outside, so it is 2 into d by dx of xy. Here this is a function of y which we are differentiating with respect to x. So we differentiate it with respect to y, then multiply it with dy by dx. So we have 2x plus. Now when we are differentiating d by dx of xy, this is the product of two variables x and y. So here we have to use product rule. What is the product rule? D by dx of x, u into v is u into d by dx of v plus v into d by dx of u. So it is x into dy by dx plus y into d by dx of x plus. Now d by dy of y is 2y into dy by dx equal to 0. That is 2x plus 2 into x into dy by dx plus y into dy by dx of x is 1 plus 2y into dy by dx equal to 0. So you have 2x plus 2x into dy by dx, open the bracket, plus 2xy plus 2y into dy by dx equal to 0. Now we take the terms with dy by dx on one side and the terms without dy by dx on the other side. So we get 2x into dy by dx plus 2y into dy by dx equal to minus 2x minus 2xy. Take dy by dx outside, so inside the bracket you get 2 dy by dx into 2x plus 2y equal to minus 2x minus 2xy. Now you can write dy by dx as minus 2x minus 2xy upon 2x plus 2y. You can take 2 as a common factor from numerator and denominator. That is dy by dx equal to minus of x plus xy divided by x plus y. So this is how we find dy by dx in this case. Let us take one more example. X cube plus 3x square y plus y cube equal to 1. This is also of the form f of xy is equal to 0. So we take first step, we take d by dx on both sides of the equation. So you have d by dx of x cube plus 3x square y plus y cube equal to d by dx of 1. We take it term by term. So it is d by dx of x cube plus 3 into d by dx of x square y plus d by dx of y cube equal to d by dx of 1 is 0. Now d by dx of x cube is equal to 3x square. We apply the formula d by dx of x raised to n equal to n into x raised to n minus 1. So d by dx of x raised to 3 is 3 into x raised to 3 minus 1, that is 3x square plus 3 into. Now again this is the product of two functions, x square into y. So we have to use product rule here. So it is x square into dy by dx plus y into d by dx of x square plus. Next we have d by dx of y cube. So this is a function of y which we differentiate with respect to x. So we differentiate it with respect to y first, multiply by dy by dx. So this is 3x square plus 3 into x square into dy by dx plus y into d by dx of x square is 2x. d by dy of y cube, it is 3y square because we have d by dx of x square is 3x square. So d by dy of y cube is 3y square. So we have 3y square into dy by dx equal to 0. Now here we open the bracket, it becomes 3x square into dy by dx plus 3 into 2, 6xy plus 3y square into dy by dx equal to 0. We can see that some terms are with dy by dx and some terms are without dy by dx. So we take the terms with dy by dx together on the LHS. So we have 3x square into dy by dx plus 3y square into dy by dx equal to, take the terms without dy by dx on the RHS. So it becomes minus 3x square minus 6xy. Take dy by dx outside. So inside the bracket you get 3x square plus 3y square equal to minus 3x square minus 6xy. So when you divide, you get dy by dx equal to minus 3x square minus 6xy divided by 3x square plus 3y square. That is equal to, you can take 3 as a common factor. Cancel the common factor. So it is minus of x square plus xy divided by x square plus y square. So let us take another different example. X into sine y plus y into cos x equal to 0. So this is also an implicit function. So first we take d by dx on both sides. So we have d by dx of x into sine y plus y into cos x equal to d by dx of 0, that is 0. So we have d by dx of x into sine y plus d by dx of y into cos x equal to 0. Now here we have to use product. So we have x into d by dx of sin y plus sin y into d by dx of x. Now again for d by dx of y into cos x, we have to use a product. So y into d by dx of cos x plus cos x into d by dx of y equal to 0. So we apply product rule to find derivatives of both the terms. So it is x into, now d by dx of sin y. Sin y is a function of y, so to differentiate it with respect to x, we have to differentiate it with respect to y first and then multiply by dy by dx. So dy by dx of sin y is d by dy of sin y into dy by dx plus sin y into d by dx of x is 1 plus y into d by dx of cos x is minus sin x plus cos x into, this remains dy by dx equal to 0. So you have x into, now d by dy of sin y is cos y. So it is x cos y into dy by dx plus sin y minus y sin x plus cos x into dy by dx equal to 0. So here also we can see that some terms are with dy by dx and some terms without dy by dx. So the terms with dy by dx, we take it on the LHS. So you can take common factor dy by dx from both these terms. So you get dy by dx into x cos y plus cos x equal to, this minus y sin x, when it goes to the other side it becomes y sin x plus sin y, when it goes to the RHS it becomes minus sin y. So now you can divide and write dy by dx as y sin x minus sin y upon x cos y plus cos x. Let us see one more example from this. Find dy by dx, x into log y plus y into log x equal to 0. So since it is an implicit function, we take d by dx on both sides of the equation. So d by dx of x log y plus y log x equal to d by dx of 0. We separate the terms, so we get d by dx of x log y plus d by dx of y log x equal to 0. This is the product of two functions, so we will have to use product rule. So we have x into d by dx of log y plus log y into d by dx of x plus, again for this d by dx of y log x, we have to apply product. So it is y into d by dx of log x plus log x into dy by dx equal to 0. So it is x into, now d by dx of log y is d by dy of log y into dy by dx. We differentiate differentiate it with respect to y, then multiply by dy by dx plus log y into dy dx of x is 1 plus y into dy dx of log x is 1 upon x plus log x into dy by dx equal to 0. Now dy of log y is 1 upon y. So you get x into 1 upon y into dy by dx plus log y plus y upon x plus log x into dy by dx equal to 0. Now we take the terms with dy by dx on LHS and terms without dy by dx on the RHS. Take dy by dx common factor. So dy by dx into x by y plus log x equal to minus log y minus y upon x. That is dy by dx into x plus y log x upon y equal to minus x log y minus y upon x. So you can write dy by dx equal to minus x log y minus y upon x divided by x plus y log x divided by y. That's equal to minus x log y minus y into y. This y will go to the numerator and this x will remain at the denominator. X plus y log x. That is equal to minus y into x log y plus y upon x into x plus y log x. So this is our dy by dx.